All right, every chapter in pre-calculus is radically different, so we take a strong right-hand turn, and in chapter 4 we are looking at exponentials and logarithms. So we're going to start, as we do most things, learning how to graph them. Understanding what the graphs look like and the components of them is going to really be an asset for you in calculus. So I would take some time and I would memorize these. An exponential is of the form y equals b to the x. Now, I can add and subtract different numbers around here, but this is kind of the parent, this is the parent graph. B is going to be a number like 5 or 7 or 10. X is in the exponent, and what makes it an exponential is you have x's in the exponent. So if I have like y equals x squared, this has exponents, but the x's aren't in the exponent. This is a polynomial, not an exponential. But if I go y equals 2 to the x, now this is an exponential. Okay. The basic graph, which I would memorize, it always starts at 0, 1. So start points are at 0, 1, and 1 comma b. I'm going to call this value b. Whatever the base is that starting value. So if it's a 5, it'll be 1 comma 5. If it's a 10, it'll be 1 comma 10. There's also an asymptote at y equals 0. So it's right here. That means the graph is going to get magneted towards that, but never touch or cross. And they look like this. That looks like it has a corner on it and it's not supposed to. So let me try that again. Comes like this, and it's kind of a smooth curve up, and then it goes really steeply up. Now, it's really easy for students to think that there is a vertical asymptote. Because it goes up so steeply, it looks like it's got an asymptote, but there are no vertical asymptotes on these exponentials. There's only a horizontal asymptote at 0. Now, when we did all the shifting of the parent graphs, I told you were going to hear that lecture 4 more times this semester. This is one of them. So we can shift all of these things, and the shifts work exactly the same way as they did before. So what I'm going to do is write you an example of an exponential and show you all the places where something can be put. So you can have a negative sign out in front, and then I'm going to choose 5 as my base, okay? So this, let's see, let me do it this way. The equation is going to be y equals 5 to the x. That's your base graph. Then in color, what I'm going to do is I'm going to put places where things can occur. Right here, you could have a negative sign. In front of the x, you can have a negative sign. You can have up with the x a plus or minus a number. And down here on ground level at the back or the front, you can have plus or minus a number. Now let's talk about what all these things do. This negative out front does what all negatives out in front do, and that is going to flip your graph down over the x-axis. Okay, remember when we were doing this, y equals the square root of x, and you have a negative out in front, that flips it down. So same thing here. If you have a negative up here on the x, it does the same thing as a minus sign inside with the x would do on a root, and that is it flips it over the y-axis. Numbers up here with the x in the exponent do the same thing as numbers that are under the root. It's going to shift you left or right, and it's going to be opposite the sign. And then these numbers at the back do just what numbers at the back of the roots do, and that is shift you up or down. Same sign. Okay, so that's the general idea, and let's just do a couple of examples. Okay, here's one. First of all, I identify it as an exponential because there's an x in the exponent. So I know it's an exponential. And the first thing that I do is draw my parent graph. I cannot tell you how many people in calculus see an exponential and they have no idea that there's an asymptote involved or anything of what it looks like. And if you can immediately come up with a picture in your head, you will be so much farther ahead than everybody else. So this is really important. What I would do is put this right here on a note card. On the front, I'd put this formula, and then on the back, I would put this shape and just practice drawing that. So here's my parent graph. I always go through 0, 1, and then I have 4 is my base. So I'm going to go through 1, 4 also, and I have an asymptote here at y equals 0. So my graph's going to look like this. That's my parent graph. Okay. Now, rules about flips and shifts still apply. We do flips before shifts. All right, so I'm looking for minus signs here and here. Since there's not one up with the x, the only one I have to deal with is the minus sign that's out in front of the exponential, and that's going to flip it down over the x-axis. So instead of 0, 1, it becomes 0, negative 1. Instead of 1, 4, it becomes 1, negative 4. And again, when I'm grading these, I'm grading these 2 points for accuracy. So transition them well and carefully. After I do that, I'm going to take the orange graph and I'm going to do my shifts. So this 2 is a right-left shift opposite the sign. So I'm going to go left 2. And this negative 1 is an up-down shift, true to the sign. So I'm going to go down 1. So I'm going to take this orange dot and move it left 2 and down 1. This orange dot and go left 2 and down 1. Now listen, your asymptote also does this. It's going to go left 2. Now it's a line, so going left 2 doesn't do anything, but the down 1 does. It's going to shift it from here, down 1 to here. So here's my asymptote, and I want that marked on your final answer. And so it's the orange graph, but shifted rigidly left 2, down 1, and this is your final answer. Okay. Now, homework problems are also going to ask you about domain on this. So domain on all exponentials are always all real numbers. Why? Because there's no vertical asymptotes. There's no restrictions in this direction, like it doesn't stop here. Even though it looks like it might, this graph right here keeps going up and to the right forever. And it goes left and gets really flat to the left forever. So the domain is all real numbers. Okay. And if you want to, you could just memorize that. You could throw that on a note card if you want to just not think about it. And not, because some people are like, oh, there's a vertical asymptote, so the domain's restricted, and that's the wrong path. The range, however, is a different deal. The range is what are the y values that this function is inhabiting. Now remember, we're looking at the pink graph. So the range is always going to be your asymptote down or your asymptote up, depending on if it's been flipped or not. So here's my asymptote, and my graph is below that asymptote. So my range y values are going to be -1 to -infinity. And since -1 is an asymptote, that's going to be a round bracket. Okay. Oh, That's backwards though. Sorry, I wrote that backwards. My bad. How about negative infinity to -1? Small to big. Okay. Next example. Okay, we need to figure out what our parent graph is and what our base is. So I'm going to start that out in orange. Our base is 2. It's the number with the exponent on it. So my start values are 0, 1 and 1, 2. Asymptote at y equals 0. Here we go. Shifts and, flips before shifts. So flips, there and there is where I'm looking for my minus signs. I only have one, it's on the x, so that means it's flipping it over across the y. So this one, this dot stays there, but this one transfers over here. The asymptote also flips, but it flips onto itself, and so that doesn't really change anything. Okay, so the pink graph is the flipped graph, and now I'm looking for shifts. So up 5, there's no number up here with the x, so there's no right or left, it's just an upshift. So I'm taking the pink graph and I'm shifting everything up 5. And the asymptote gets shifted up 5 as well. So it should look like the pink graph, only moved. Okay, the blue is our final graph. And let's check out the domain. Domain, all real numbers. Range is going to be my asymptote up or asymptote down. So here's my asymptote and the graph is above it. So my asymptote's at 5 all the way up to infinity. Okay, y values, x values. All right, now there's one other thing in this homework that might be new. You have a problem like this. What in the world? What is this? Okay, E is kind of like pi. It's an irrational number that pops up all the time, and it pops up so often that we gave it a name. Okay, E is roughly 2.7. Okay, it's like, I think it's 2.71. I can never remember exactly. Okay, but it's 2 and some change. All right, that's what you need to remember. And so it acts just like a number. And if every time you see E, you just think 2.7, you'll be in business. Now, don't let anybody see you writing anything this way. But if you want to, and it helps, you can do this and then erase it later. This is 2.7 to the negative x plus 2. That's what it's saying. Okay, and so all that does is it changes your start value. All right, let's draw. Please grab some graph paper, make these accurate. I do not want crazy sketches on lined paper. I'm going to give you 0 for your homework, so don't do it. Intercept at 0, 1. And then my base is going to be at 1 and 2.7. So it's just an estimate right here. This is that E value. Asymptote still here at y equals 0. Shink, shink. Okay, that's our parent graph. And now you can forget about that and do everything else as normal. All right, in this case, we've got 2 flips. So I'm going to do one at a time. First, this one out front is going to flip it down. So we go like this. And then the one up here with the x is going to flip it over. So it does this, okay? Then I'm going to do my shifts. This is going up 2, so I'm going to take the blue graph and move the points up 2, and I'm taking my asymptote and moving it up 2. So it's looking like this. Green graph is the end guide. And domain, all reals, all the time. Range, here's my asymptote and my graph is below it. So I'm going to go negative infinity to my asymptote, which is 2. Done. And that's all the E is. Everywhere you see it, just write in 2.7 and proceed as normal. One last thing I want to tell you about graphing exponentials. We always want to look at our exponential with a base as a whole number, not a fraction. So if you get an equation like this with a base of a fraction, I want to show you the trick for converting this to a whole number. You're going to first distribute the x in to the power on the top and the bottom. You can do this because it's division. You cannot do this if it's addition subtraction. That's black magic. And 1 to any power is just 1. So this ends up being 1 over 3 to the x. And then if you remember your power rules from Algebra 2, if you want to take this upstairs, you can do that, but what you do is you change the power, the sign on the power. So really, when you have a fractional exponent, what's happening is it's the base of a 3, but it's being flipped across the y-axis. So this is the trick that you're going to do to convert all of your fraction bases to whole numbers and then proceed with your graphing from there.